see it. Oh, he's there. No, he's not logged in yet. All right, we'll get started in just a minute. This is the EMU session, so hopefully you're in the right room. All right, since this is the first meeting of the week, you all should familiarize yourself with the Note Well, basically outlining the rules of participation in the IATF. If you're not familiar with this, you should be. So we'll sit on this slide for a brief minute so you can take a look. It is, yeah. There are plenty of seats up front. If you can't see the text in the back, you can always move further forward. All right. Any questions on the Note Well? Hopefully not, because I don't know if I can answer them. All right. So for the agenda here, we have a number of drafts, both working group items and some also proposals that are new and have been discussed before that are not yet working group items. We have the blue sheets going around, so make sure you sign them so we get the correct size room for next time. And we have somebody in Jabber. We have and Max for taking notes. We will have some remote participation today. I see Alan's on the Miteco. And so I think our first presentation will be EPKA update from Yari. Somehow we can, there, that one. It should be that one. And then we go to that. And then click that thing here.
Okay.
Yari,
So
if you want to switch your own slides.
can you hear me? Yes. So this is a brief update on comments that we received sort of during or after or slightly before the working group last call that has now ended. I think positively, my interpretation, of course.
Is that working? The arrow key.
Oh, there we go. Doing it wrong. Right there. So this is a draft that was, I mean, I'm not going to go through all this, just sort of a reminder that there's like basically two reasons why this draft was written. One is that some new technology got developed, 5G, and it has, some things that has to be taken into account when it comes to EAP AKA prime. And secondly, of course, the world has also otherwise moved on, and we've discovered, more security vulnerabilities and other facts that need to be sort of documented. So we made an update for all this. And here I've attempted to summarize what the feedback has been. So as far as I can see, no roadblocks here, but a number of small items, a number of sort of editorial things, some clarifications on how the updates obsolete language actually should be written from Daniel, for instance. Some technical clarifications, like where exactly is this the length field calculation defined, and in a version that I have on my computer, this is actually pointing to the RFC that defines that, and so on. We also had some discrepancy between different drafts on whether to use the hexadecimal or decimal format in session ID definitions, and I know that doesn't really matter, but maybe a good thing to align, and I think all the other documents actually use hex, so I'm going to change that. And then there's a couple of other things that may be worth discussion a little bit more. So I have one slide about one issue around the permanent identifiers that are used by 5G and how they're fed to the KDF in this protocol. There's a recent question about that for a day or two ago from Marcus Wong in Huawei. And there's a question from Daniel on one of the statements in the security consideration section that basically talks about identity privacy, and the current text says something along the lines of, you can refuse to send the permanent identity if you believe that the other side should have your pseudonym, and he was interested in upgrading that to a should, and I think that makes sense. There's also been some reports of some new attacks. These, like the underlying algorithms and the mobile network security in general, it's obviously an important thing in the world, and also a target for researchers to look at. So we always get some new information every year, or a couple of times a year. Something new comes up, and I just want to go through one of those recent items. So we go to the permanent identifier thing first, just to set this up. So there's when EAP aka Prime is used with 5G or with 5G in general, you have two identifiers: a concealed identifier called SUKI and a permanent identifier called SUPI. And the permanent identifiers are never sent on the wire, on the clear. But in our protocol in EAP aka Prime, you actually use them in the KDF. And also the SUPIs can be either of IMSI form or free-form NAIs. And now I had a question from Marcus about discrepancy between one of the 3GPP specifications and our draft. So our draft basically represents everything when you feed the SUPI to the KDF. And now this has to be exactly right for everybody, otherwise the keys don't match, right? So we can't just wing it, we have to define it. And our draft says currently that everything is represented as NAIs, and it points to the 3GPP TSS for how to do this. And now I fear that they may have slightly changed after we inserted this exact reference. But anyway, so the draft has the idea that everything's represented as an NAI, and if it's an IMSI and not a sort of regular NAI, then you convert the IMSI to an NAI in a particular format using this 3GPP network.org construction that's also used elsewhere. The 3GPP technical specification has this, doesn't actually today have a format because it's sort of like an abstract specification, but the abstract specification says you have a type followed by the actual value. And now we don't have a type. We just, like, both of them are NAIs. And of course you can tell them from each other, but there's no like type field. So that has to be resolved somehow. I got this question very recently, or observed this very recently, so I don't have an answer yet. I don't know if people care here that you come to the mic and explain what you would like to see. But other than that, I'm in discussion with some of the 3GPP people, and we're trying to come up with some answer. Like, I personally don't really care what the answer is as long as it's clear. But that's the requirement, that the draft needs to specify that this is the way, and end of story. Otherwise, we have a problem.
So the internet draft will have the full specification for it, or will it still be referencing?
Well, it will in any case be referencing the TS, because the TS has most of the components. Right now, I don't think it actually has the full top-level thing, but it will have the components. So there's, in any case, going to be a reference. Right. The only question is if we're referencing the parts about this 3GPP network.org thing, or we use some character followed by either this or that, and that's the only.
Okay, thanks.
And since this is not on the wire, I mean, this is very important for interoperability, but it's not on the wire. It's only on the math.
But it might as well be, right? I mean, why does that make a difference if it's not on the wire?
Well, I mean, I'm just describing what the situation is. We're not sending it, but it still needs to be right.
Right.
Perhaps even more so than if it was on the wire. So we're going to resolve that in some fashion and move on. Also, there's been some new attacks, or some of these attacks usually develop over a couple of years. I think this particular one that I'm pointing to, this ePrint link, is originally maybe 2016, some Black Hat conference or something, and then later published as this one, and then we got some news late last year or early this year, which caused some people to ask about this, like how does this affect your protocol? I have an understanding of what this attack is, and I'm trying to explain what the consequence of that is. But first, I want to go through this principle, which I have had, which is that when we, in this working group, when we do an authentication protocol using somebody's sort of base procedure or algorithm or protocol, like we do here with the 3GPP's AKA procedure, then it's our job to use those algorithms and procedures, and we need to document the security properties. So if there's an issue, we should document it. But if the underlying algorithm, for instance, should change somehow, then I don't necessarily feel that I should or we should change the thing, that it's better if the original providers of the algorithm actually change. And there's an ongoing discussion in 3GPP about this particular case, which has not resulted in any changes, at least as of now. And it might in the future, but I don't want to diverge at the IETF and start using a sort of our variant of AKA. I can build things on top, and I can describe the security characteristics, but I think we should stick whatever 3GPP has, and they are in charge of updating the core thing if they want to update. Okay, and then there's the question of what, like, for this particular attack, like the draft already describes a number of different potential vulnerabilities and their impact or lack thereof. This one is sort of in the is in a category of attacks that there's also some other ones or previous ones. And if I have understood correctly, then the category is essentially that you take some information from a previous run of authentication, like you observe a cell phone here, and it's been authenticated, and the attacker observes that, and then it later can replay that selectively back to the phone at the later time, or possibly at a different location. And now, given this, you can actually observe something. So one basic and well-known attack is that you can, because in the AKA procedure, you can basically try to authenticate a phone or a SIM card, and you could get two types of answers, or three types. Like, of course, you can succeed with the authentication, but you can also fail. That, I mean, the crypto is just wrong, or you can get a sequence number failure. So this would allow you that if you record an authentication run and then you replay that later, then you can figure out that, okay, so now he said sequence number failure, so that means that it is the same node, and so we see that sort of break the identity in some sense at least. And this new ePrint thing is somewhat similar. I don't want to go to the crypto, which I don't necessarily fully understand in TADAC how they do it, but they construct some of the challenge values and modify them appropriately, and as a result, they can recover some of the bits of the sequence number in the exchange, which means that, okay, now you know a little bit more about, you can't like hack the actual authentication, but you can recover some amount of information about what sequence numbers are being used. And again, in AKA, the sequence number keeps increasing as you make authentication. So this would tell you maybe a little bit about the identity of the device, as well as how many times it has authenticated in between. So which might tell some things about, like, how, where else it has been, or how many times, and so forth. So this is the theoretical part, and there's I don't think there's dispute about, like, what's going on so far. But the more interesting question is that I think this is why the 3GPP hasn't actually done anything yet about this. Is like, how can you use this in practical sense? Because the problem is that for these attacks to work, you sort of have to feed, the sequence from this phone. You have to refeed it to this phone, and particularly with 5G, there's no identity on the wireless interface. Like you can't figure out like which device this is. So you essentially would have to feed like all information ever in the information from every phone elsewhere into every new device that you don't know which one is, and then you might learn something, which is maybe impractical. You might be able to do this in some more limited case where you're only tracking one device, and you knew something about the location of that device, so you had a good reason to suspect that this is that device. But then you would already have some information about where that device is. So it's not clear that this is like a hugely practical attack. And that's a long explanation. I was going to insert a very similar sentence that I've had in the draft for other attacks. That this is roughly the impact. This is what the attack is, and this is the impact. So one new paragraph. Okay, so that's basically it. My plan is to work this week. I've already sort of half implemented these changes in my own copy. I want to try and complete that. There's some discussion with over email with some other people from 3GPP and so on about the alignment between the TS and this. And then I plan to resubmit the draft, and this I think would mean that you guys could, for instance, start the IETF last call if that's the next step.
Good.
So that's all I had.
So with respect to that particular attack, is the 3GPP looking at anything? Is this something? It seems like it's something that's fundamental to AKA, and not. And even if you were going to fix this, would it have? Do you think it would have impact on EAP AKA or?
Mohit, so I read the paper. My understanding is that you have a phone and you have a network, and they have sequence number.
Yeah.
And this sequence number is not sent out, but you can be out of sync, and then you need a procedure to resync the sequence number.
Right.
That was my understanding. So 3GPP has a procedure of resynchronizing when you get out of sync between the phone and the network, and they miss or the attackers use this mechanism to decipher bit by bit and decode the sequence number. And the countermeasures are like you can export another key and encrypt the sequence number, but the resync procedure has, as far as I understand, nothing to do with EAP AKA.
Right.
That was my understanding.
Yeah, that's my understanding. So this is an AKA attack, not an EAP AKA attack. Now, if 3GPP goes off and designs a solution to fix this, it might or might not happen, then we don't actually know what they would do. Like they could totally redesign, and then we have to do something. Or they could do something that's totally invisible to us. So at this point, it's sort of it's difficult to do anything. And my recommendation would be to not do anything. If they actually address this, which personal opinion may be a little unlikely, then we would potentially have to do an update or take into account or something.
Okay.
So if they decide to fix this, won't it? Like, would it require new messages on the wire? Because my understanding was it won't require any new messages on the wire. And if there are no new messages on the wire, EAP AKA is not affected.
So I think that's true of at least some class of I mean, you're asking me to make a statement of what the a potential future solution is. And I know you have some ideas of what those might be. I have some, maybe a somewhat similar list. Somebody else might have some other things. I think that would make a lot of sense to have a solution like that for 3GPP if they did something. But I mean, I can't rule out that they do something more, but that seems likely.
Max Pana, Cable Labs. Small question. You mentioned about identity privacy considerations. are those related just to the SUPI and the format, so to make sure that the keys are correctly rated, or there's something else?
Yeah. So there was. So the draft actually has quite a bit of discussion of identity privacy. So today I brought up this, like, well, that we have a possible interoperability question mark about exactly how to feed one piece of data to a KDF, and that one piece of data is the actual permanent identity, but the permanent identity is not communicated in the protocol. You have concealed identity, which is encryption, but there's other mechanisms like the pseudonyms which may not be so useful at this point in time. The draft actually says that. So there's a full discussion of all of those different cases in the draft. So I don't think we have an issue as such with identity privacy. Thank you.
Roman Danilio. So back to the idea of what to do, given that we can't predict 3GPP's behavior, I would honestly just document the state of play so we have it in the security considerations, and then that may change, but so as the document progresses, there's no confusion. Did you guys think about it or not? So it's there.
Yeah, exactly. And also, since we do know this space, we know that there will be the next attack, and like we couldn't wait forever, then we'd not do anything.
Hello, Stefan Santosson, AAA Security. I hope these questions make sense because they're not really from me. I was asked to relay them, but sorry. I hope these questions just make sense. The first one is there apparently has been some threats about downgrade attacks, and the question is whether they have been taken care of. And the other is, like, do you expect this to now materially stay the way it is, or is there any material changes coming to the draft?
So I, other than this, like the two and a half things that I talked about now, I don't expect any material changes. So this is basically it, where I'm tweaking the final bits. And downgrade attacks have been part of the design since RFC 5448, and there's a discussion in the draft about like how, you know, what the protection for that is, and also how this new RFC, whether it has any new issues. And I think we covered it. If you have more specific questions, we could go into that. But that's the high-level answer. That there's a section on downgrade attacks and security considerations piece that talks about that.
So we're waiting on a revision from you then. Okay, John.
Thank you. So this is a presentation EAP with TLS, EAP TLS with TLS 1.3, and okay, good. Closer to the mic now. So there's been 2 updates to submitted versions since IETF 103. Version 03 did 2 things. It mandated privacy protection of identities to mitigate pervasive monitoring. Earlier, TLS 103 mandates protection of identities in the credential, but there was only a should on protected identity in the identity response. Now it's mandatory to do so. Then the draft highlights that there is a difference between TLS fatal alerts and warning alerts. RFC 5216 only talks about alerts, and I think it basically only talks about alerts as fatal alerts. You terminate the connection. 04 version has quite a lot of changes. We got people, Alan started implementing and did a very thorough review, and also other people. So one change is that the document borrowed the term privacy-friendly identities from RFC 5448 bis. And it also borrows some privacy consideration from that draft. There's a new figure describing EAP TLS without peer authentication. This is used in, for example, emergency services. There is mandatory revocation checking and mandatory OCSP stapling, at least from the server to the client. The client must send this extension to the EAP server, and the EAP server must send OCSP status responses for all the certificates. Then there are new security consideration on discovered vulnerabilities in earlier version of TLS, just referring to this use of TLS in application drafts. And then there are some security consideration regarding to revocation, why it's important, and what you can do to prevent it. Then there are several clarifications to the key derivation section. We will have a talk slide later. There's a type code to mention that you cannot truncate the length of the key after you have derived it. There's text about using this key derivation in other TLS-based EAP method, and then it's a copy-paste. Copy-paste the MSK and EMSK derivations from RFC 5216. Then there are new text on identity verification, authorization, and resumption. Suggested and even suggested text by Alan. We'll discuss this later as quite a 1.5 page of security consideration. And there's comments from Jim. There's clarification about the unfragmented messages and the LBIT, as suggested by Oleg. And then there's we removed the 5216 requirement to not protect application data. Early application data is still forbidden. The submitted draft, that's been comment from Elliot, whether that should be the case. We will discuss that later. So I have 5-6 slides on things that I need to have a little bit more discussion and maybe take a decision, or if nobody comments, we will go with what is in draft. So unfragmented messages and the LBIT was pointed out from Oleg Pekar a couple of weeks ago. The old RFC is quite ambiguous about this. It doesn't really say anything. Then EAP TLS states that you may set this bit in unfragmented messages. This bit and the length is used in, if you use fragmentation, this bit is always used. I have checked, there's no other RFCs discussing this. There was information from Oleg that some implementations reject unfragmented messages with the LBIT set. And there was comment from Alan what Free Radius is doing. And basically, the latest version on GitHub copies the behavior of what Alan suggested, that implementation must not set the LBIT in unfragmented messages, but you must accept messages with or without the LBIT. And unless there is any further comments on that, we will take that approach. Then TLS hello retry request was realized here after a comment from Jim that the draft does not say anything about hello retry request. Hello retry request is a new message in TLS 1.3. It's similar to hello, I don't remember, similar to another message in DTLS 1.2 that does basically the same, similar things, but it has a different name. It's a new message. So the next version of eTLS should probably mention this. Jim has suggested that early data should be forbidden, but that should go with whatever we decide for early data. And then the question is, would the group like a picture describing hello retry request? Earlier there has been comments wanting figures and message for basically everything. Then I think I will maybe add a picture. Let's see. Key derivation. So this was changes here was based on comments from Alan, and the comments was based on the use to use this key derivation also in all the other TLS-based EAP methods. It's people wants to use TLS 103 also in these other methods and want to use the EAP TLS specification as a basis for that. So the key derivation in the document was made more general. It now includes, before it just had this number fixed, now it's defined type code as this, and you use the type code as context in the TLS exporter and also as part of the session ID. Then it's defined that the type code is 1 byte or 4 bytes. Right in these slides, I realized that now I don't remember which RFC number, but the one that defines session ID also defines session ID for extended types. And these are longer than 32 bits. They have a 1 byte type code FE, and then they have a 24 or 32 bit vendor ID, and then some vendor type. What do we do with these? Either we need to specify something or basically say that you cannot use these extended types with EAP TLS 1.3 or any other EAP-based, TLS-based EAP method.
Mohit, I didn't have a comment on the extended types, but maybe just some note on adding the type code as a context. So this is implementation report from WPS applicant. Some of the TLS libraries, OpenSSL actually supports you to send the context and context length. But Wolf SSL and some of the other libraries, because no one was using this in the TLS exporters, even though 5705 defined that you could have a context and a context length, send that to the TLS exporter. Some libraries didn't implement it. My comment here is that we should do this and then force the libraries to follow the RFC 5705 more precisely. And this is now, my colleague sent a pull request to the WPS applicant. This has been accepted for OpenSSL and the internal TLS libraries, but Wolf SSL doesn't even allow you to send a context value and context length. But this will hopefully force them to follow the RFC more closely.
Yes, good. Did you have a comment on the extended types? No? No. Okay.
So the extended types, this would come into play more so in the tunnel deep methods. I mean, why would it matter in EAP TLS?
Alan wants to use the whole reason to include the type code here is to refer to this from all other TLS-based EAP methods using TLS 103.
Right.
They also need to define how the keys are derived in a new way.
Yeah. So, and you could support either having the type code or the extended type code, right?
Yeah.
So
I think it's very easy to add a new line to say how you use define session ID in extended type codes. It's not a problem.
Yeah, it seems like you should do that.
Yeah.
I mean, or else somebody defines a TLS method that uses an extended type, then we have a problem.
Yeah.
Maybe speaking as an author, my thought was that other methods that use TLS as the outer tunnel, let them define how to do this. We only do for EAP TLS, because we can't predict and we can't go around fixing all other EAP methods that use TLS in the outer tunnel. And since Alan seems to have a document that deals with those methods, maybe these extended types go there, and we stick with what we have right now. But
yeah, let's decide we fix this somewhere, but I have a slide later how the division between this document and other documents should be.
Okay.
Yeah.
Hi, Elliot Lear. Just to follow on what Mohit was saying, actually, that I think that's probably a good general philosophy, that there are going to be things, and we'll come to my comment actually, where having said my comment, I'm going to withdraw it. But in terms of what I said on the list, because I think it may not be appropriate for this draft, but it certainly will be appropriate for other drafts. And so the issue here is that TLS 1.3 is going to get smattered across all of these drafts, and Alan's draft is going to be, I think, important to set a principle there, but we have to be careful as to how we apply that principle on a per draft basis.
Yeah, good. I think it should be in this draft or Alan's draft. I think that's the two options. We should not wait for some, probably. Next slide, early data. And here the draft said must not use early data. Then there was a comment from Jim that wanted a positive statement, i.e. not must not, but instead what you must do. And the discussion on the list, my suggestion then was to talk about hello retry request. But now making these slides, I realized that only covered the 0 RTT data when the client is sending an early data extension. And then the client can send early data and the server can send early data. Looking at the TLS 1.3 specification, at least according to figure 3 in that specification, the server can send early data even if the client has not sent the early data extension. I don't know if early data is it's not 0 RTT data, it's application data star here in this figure. This figure is taken from TLS 1.3. The RFC doesn't say anything else about the use of this. I would say, according to RFC, this is allowed, but it might also be a mistake in the figure. Yeah.
That actually is allowed. But one of the statements that we've made is you shall not send data when doing EAP-TLS. So, yeah. I mean, if you receive any application data segments, I think that's probably something that you should probably roll over and die on.
Hi, Sean Turner. So I think if we're going to use early data or not, if we're going to use early data, we must say something, because the TLS 1.3 spec is pretty clear about if you're going to use it, you got to say something about it, because there's warnings, like a page of text in the draft that says if you're going to do this, say something. So one way or the other, you need to say something about it.
I think it's pretty clear that EAP TLS 1.3 does not have any use of application data at all, except that it sends an empty application data to convey information. But yeah, so it's more about other EAP TLS methods.
Yeah, fair enough. Thanks.
Yeah, so it might be options are, this draft says EAP TLS does not use application data at all. Other drafts referring to this may, or via say must not, and then let some other draft handle it.
Mohit, I agree. We should just say EAP TLS doesn't use this, and then let others define what they want to do.
Yes. So here's the slide discussing this division between other TLS-based EAP method, and the question how should the EAP TLS 1.3 draft deal with other methods. Alan has been suggesting text that this draft also specify things for other TLS-based method, and currently the draft is a kind of mixture between different approaches. Mohit has a strong suggestion to say must not. I don't really have a strong opinion, but I think we should have it should be similar for everything in the whole draft. Right now it says that for key derivation, we have some text describing what other EAP methods may do. The key derivation is adopted to other methods. For early data, we have a must ignore, but then we have protect application data, other TLS-based method may. And the third case where other TLS-based method comes in is cross-method resumption, which we have not really, there's been discussion, but definitely no decision, because there's been enough discussion on resumption for EAP TLS only. Yeah.
Okay, so this is the text in your current draft?
Yes.
All right, this is Elliot, by the way. I have a suggestion here, which is, why don't you stick to your draft? Right? Don't worry about modifying other methods. Just deal with your method.
Yeah.
Right. So text such as that refer to other methods, let that be for other methods. And if they want to reference your draft, that's fine. By the way, which I probably will.
Yeah, and I think that's a good way to go. There's no point in including all the other methods things in here, and going too far down that path will lead to pain. I think probably with respect to early data, since we don't expect to get early data in TLS, I mean, it has no use. It probably ought to be maybe stronger than ignore. Because that could be a sign that somebody's really confused.
Yeah. So basically, it's quite strong, only focus on EAP TLS, quite strong wording here, and ignore. Then wrong button. And then maybe, would you say remove these things or move it to some session, summarize that other methods may use? Should it say anything about other methods anywhere in the document?
I guess I'm not sure. I think we'd have to see. I think this discussion of what other methods do belong in another document. Yeah. I think the place where I might be a little bit conflicted is, the only method that should use EAP TLS's method ID should be EAP TLS, and nobody should copy this key derivation with the same key ID to another TLS method. But I think that's really a topic for the other draft.
Agreed.
Okay.
Yeah, so I agree with Joe's suggested requirement there, the little one. But I was actually mostly working on something else, but I woke up when you had written cross-method resumption there, and that got me really scared. And so please tell me that cannot be done.
So, Mohit, as author, that should not be done, but we have had discussions on the mailing list, and Alan seems to want to do this. I'm against this. I support Jari in being against this cross-method resumption. So, if I run a network where peers use EAP-TLS for authentication, I don't want to see any other EAP methods. And if some other EAP-TLS start using the method ID of EAP-TLS, that would be like bad for running my network.
I think we have at least taken a decision that this will be handled by Alan's draft instead. I did not see any. There was a lot of discussion on the list, but I don't think there was no really conclusion whether this was what the concrete security attacks was against this that did not, or at least there was disagreement what the attacks was when doing cross-method resumption compared to, is that really worse than single method resumption or not? Yeah. That's the last slide. So text on identity verification, authorization, and resumption. So Alan suggested quite a lot, suggested that this was missing and proposed quite a long text for the security consideration regarding this. And this is concerns quite several sections. It concerns the identity verification, which talks about the identity in the identity response. It concerns resumption. What do you say from the first full handshake, and how do you do to securely do resumption? What do you do if something has changed between the full handshake and resumption? And then it concerns similar authorization is similar to identity verification in security consideration, resumption in security consideration, and then it also may affect revocation a little bit. Jim reviewed this, suggested that some text move from the security consideration to the main body, also suggesting that some text should be removed. And the text Jim did not like was the text talking about other authentication information, what should be cached, and what information should this draft discuss. Alan suggested text discussing caching of information about the authenticator, information about the e-peer, information about the EAP protocol layers below EAP. Could be MAC address, IP address, port numbers, Wi-Fi, SSID, etc. Jim's comments suggested only caching information from the TLS handshake. And I think, listening to Alan and others, this seems to be what implementation is doing today in practice is to cache a lot of information, or at least they use a lot of other information for authentication, maybe, and this may or may not, it may be trusted or not trusted. Mainly they do filtering. If you're not on the correct range of IP address, you're not even considered for authentication. Writing this, putting this into the document, I found it quite hard to differentiate between the terminology to use here. And I'm not sure there is some easy process that you can write that maps to this. Yeah.
Mohit, so EAP is run before you get IP address. So I wasn't sure which IP address are we referring to here. It's probably the IP address of the NAS or the access point. But maybe the concern here is that EAP methods don't have access to this information. EAP methods don't have access to the BSS ID of the AP through which the EAP messages are coming. Currently, we may decide to change EAP and do better channel binding, for example, but currently we don't have access to this information inside the EAP method. At least in the implementation I have. Maybe Alan can.
Okay, Alan, you're on.
Okay, I'm checking if people can hear me. My audio works, yay?
Yeah.
Realistically, I mean, this is a comment I made in the chat too for people that are following that. EAP isn't really used by itself. It's always used in the context of an encapsulating protocol, right? Whether that's PPP or radius or diameter or PANA or anything else. To a certain extent, yes, the EAP implementation is mostly only aware of EAP, but that encapsulating protocol is available to the, I guess, larger software stack that's doing EAP. And what we've done in FreeRADIUS going back, gosh, for forever, pretty much, is take a look at this and go, oh, right, we can pretend that EAP is all by itself, in which case all kinds of bad things can happen, or we can add as much as possible about the session to EAP, to the TLS cache, so that we can make better decisions in EAP. And that motivates my suggestions here. The issue is if you only cache information from the TLS handshake, then your resumption and everything else is just, it's 100% insecure. We really do need to give people guidance as to what to do. And the only real guidance there is, yes, this draft does implement EAP TLS, but it lives within a larger context. So it's very hand-wavy. And please pay attention to the larger context.
Mohit, I am in favor of providing this information to EAP. I was just maybe saying that currently not all implementations provide a mechanism where this information is accessible to the EAP method, regardless whether it's EAP TLS or not. It's not accessible to the method, and maybe that's something we can look at.
You're on again, Alan.
Yes, I think that this is related to the earlier, or similar to the earlier discussion about Wolf SSL, right? It's yes, not all EAP implementations provide this data, but you should. It really is that fundamental to the security, I believe.
Yeah, seems to be support to keep talking about this additional information. Yes, let's just find out how we should describe it in a good way. Wanted more reviews, implementations. We have at least 2, maybe more. Interop between them. I don't know if that has been done. Would be good. And I always think that working group last call is close. We're not there yet. Now there was quite a lot of comments. Hopefully when these issues are concluded on, if there's no more issues. Yeah.
So how many implementations do we have in progress that you know of? Or?
Alan has implemented it. Joni has implemented it.
It's Joni's implementation. I've been sending pull requests, or we have been involved in that.
Yeah. Two right now.
Yeah.
Does anybody else in the room know of any implementations that are in progress? Okay.
I was just going to make a suggestion. It'd be really helpful if we tracked all those implementations, maybe on a wiki page.
Yeah, I think that sounds like a good idea. Yep. So yeah, please continue to review that draft, and if we'll try to set up a page to record implementations either on the GitHub or on the wiki.
Yeah. Great. So next presentation, handling large certificates and long certificate change in TLS-based EAP methods. And as you may or may not have noticed, the name of this draft has changed from EAP TLS only to TLS-based EAP methods, because the content of this is really applicable to all TLS-based EAP methods. Changes since last time. There's some editorial reformulation and restructuring in the document. There's a new document structure in the main body of the document. Guidelines for certificates is now subsection to updating certificates. And there's a new updating authenticators section. It will be very short, just saying why that is hard, just to be complete. So we have updating certificates, updating code, updating hardware. just fill everything. Section 4.1.1 guidelines for certificate has been, it was empty before, now it has been filled with text written by Sean Turner, which is also added as co-author. Do you want to say something about this? No. It's like a page, it gives recommendation of object identifiers, directory strings, and general names types and extensions. So please review the document and comment. That's it. More reviews, feedback is wanted. I would like to ask for working group adoption of this document. It is in the charter. I think it's in a reasonable shape now for that.
How many folks have read this draft in the room? 1, who's an author? 2, who's an AD? Okay. All right. So I'd like to see if we could get some more reviews. Can some people in the room commit to reviewing this draft? Okay, we have Elliot and Max and Thomas. And what's your name? Anoop. Okay.
Yeah. So hi, this is Sean Turner. I'm one of the new co-authors. I mean, this is foot gun protection. So it's useful that people actually read this. So if you're actually implementing this or thinking about implementing this or use this, it's a good thing to read. So that's kind of my pitch for why people should give a crap about this at all.
Awesome. So yeah, please review it. I think it seems like this is in our charter, and if we get some reviews and people are favorable, I think we can call for adoption on the list. I don't see any reason why not.
For second question, is there anything the group would like to spin off as work in the TLS working group? During the charter discussion, I don't remember several people highlighting the problems with large certificate and certificate change and authenticators cutting it off. One of the things that was discussed at some earlier meeting was that right now, to cache a certificate chain, you need to do a full handshake. Then you can use a cached. It could be possible to use a certificate from a not completed TLS handshake, but that would need to be an update to a TLS draft, and it need to be checked by the TLS working group. Is that I would be willing to drive that with somebody else if the working group would find that worthwhile. This working group would say that that's something we would like to implement and use. That would basically maybe double the certificate sizes you can use in current authenticators.
So Roman Danieli is the incoming AD for this. I just wanted to confirm. I concur it's in charter. So if you want to adopt it, good to go.
As far as for whether we'd want to do something in TL, I think we would have to have some pretty good definition of what it is we wanted to do. I'm not what you described sounds like it would be definitely, if we were going to do that, we would definitely want the TLS working group to review that, because I think there might be implications. So
I think that would be done. Yeah. I would suggest doing it in the TLS working group, not here. That would be an update to the cached information. Yeah.
Okay.
I think I will not do it unless people here say that they want it done. Then I could.
Yeah, so I think we would want to discuss those things on the list and see if people think it's useful. I mean, we just would have to see. Some of that might be pretty major work, and cached info was not a quick moving draft in the TLS working group.
Yeah.
So. So, Alan, you're up.
Let's see. There we are. Yes. So I guess this is the extension of the earlier discussion. If we just quickly go to the next slide, I guess. Excuse me. So yeah, the key derivation has changed. As everyone knows, there's RFCs for some of these EAP types, but not others. So if we go to the next slide, simple solution is to update EAP TLS to use, sorry, that should be the type code, not method type, and then update the other methods to use the same key derivation. So the reason for that, I guess, the reason for requesting that EAP TLS change is the current status is every EAP method defines its own key derivation, and it's a mishmash of this, that, and the other thing in different labels. And it's just a pain, and there's no real reason for it. Whereas if EAP TLS goes, hey, this is what we do, by the way, we're using our type code, then all the other TLS-based EAP methods can go, oh, we do the same thing, and we use our type code. I think in reference to the earlier discussion about extended types, yes, this document should suggest that. While there may be many different vendor EAP types that use TLS, and we're not really going to fix all of them, I believe it's good to give guidance, and at least in this document go, hey, this is what we suggest to do. So if we go to the next slide, the harder solution is FAST and TEEP. They use key derivations which depend on the MSK and EMSK from the inner tunnel data, and so use some fairly complex key derivations. So I've put something into this document which I believe sort of makes sense. Whether or not it makes sense to other people, I don't know. I haven't taken a look at implementing it, but it probably would be worth doing that before the document's published. So that's really the major sticking point in this document is it needs to get published quickly, and we can't publish it until we've had some review of the key derivations for FAST and TEEP. The other question is PEEP is vendor defined. There's a draft which is long expired. Microsoft has all kinds of documentation on this on their website, but it is very, very widely used. So the question is, can we update a vendor spec? The answer is I don't know. I did ping Gabriel Montenegro about this, and he's had some discussions internally in Microsoft about this. My 2 cents would be to put it in this document simply because it's a well-known EAP type, and there really isn't much to do. It's basically use the EAP TLS key definitions, but with the type code from PEEP. And I don't see that as controversial for anyone. The other thing, we may want to have some additional discussions of security here, as per the EAP TLS document, but I'm not sure. My 2 cents is we really do need to give guidance to people, and I don't like pretending that EAP is run in a vacuum all by itself. Guidance really does help people with implementations and with security. Next slide. So there aren't really security considerations with the key derivations. There are many issues related to EAP and TLS, as noted with the EAP TLS document. And the question is, how do we split those discussions up? If the goal is to get this published quickly, then we do need to get this done quickly. EAP TLS document seems to be a lot further along than this one, but they should be published very, very quickly, one after the other, I think. So I guess the larger question for the working group is what else needs to be discussed in this document, or what needs to be pushed from the EAP TLS document to this one. Next slide, and I think that should be it. Yes. Main critical things are key derivations for FAST and TEEP. Questions?
Good evening, Alan. This is Elliot. Thanks for staying up and presenting this. I think we probably have a little bit of a tangle with TEEP in particular, and especially, and this relates to the draft that I'm trying to, sort of slow roll and get right for, doing Brewski, because in that case, it's not even clear we're using an inner with TEEP. And so one of the tangles here is, am I actually using TEEP correctly in the other draft? And if I am, then is the key derivation, am I, or even worrying correctly about the key derivation in that draft correctly? And how does that relate to section 2.2 of your document? So these are, to answer all these questions, I think the best way to do it at least is to prototype a little bit, which is where I'm aiming. So at least I just wanted to pass you that feedback. So I'm a little nervous about going too fast on section 2.2, and I think you are too, given your comment.
Yeah. The other thing is there's not a whole lot of implementations of TEEP. And I would hopefully like to have implementations of this before we put something in a draft or in a published spec. Otherwise, the spec might be wrong. The difficulty there is TEEP is not trivial. So it might be a while before it goes into the standard, sort of test implementations that everyone uses, which is host AP and FreeRADIUS.
Okay, just a standard question here. How many people have read Alan's draft on the tunnel methods? We have two people who are not authors or ADs, I think. So that's a good sign. So yeah, please look at this as well. This is be pretty important to get right, since tunnel methods are a little bit tricky. I think this would probably still be within Charter. It's a little bit outside of what was defined in, I think, explicitly, but it's still handling some of the TLS 1.3 cases. Roman?
So this is Roman speaking. I haven't read this, so we can chat.
Okay, great. If it isn't, then we'll probably have some more chartering sort of discussions at the end. So. Yeah, I think are we ready to move to? I think we're ready to move to the next topic.
Just one last comment on this document. I guess one of the reasons this came up was, I guess, doing the implementation and then sort of having the realization that, oh, if we're updating EAP TLS, then we need to say something for the other EAP TLS based EAP methods too. Otherwise, there's no guidance. And as an implementer and someone who supports people, it sort of scares me to have an EAP TLS specification for TLS 1.3. And then at some time later, perhaps, specifications for the other EAP methods that everyone also uses. That seems to me to be a giant red flag. Okay, so we can go to the next document. So the session identifiers should be a whole lot less controversial. If we go to the next slide, this is based on Uni Malinen's notes from a while ago that he was trying to do this for fast reauthentication. And then notice that a bunch of things simply were not defined. So the EAP session ID hasn't been defined for SIM and AK, and no session ID derivation was defined for AKA prime or PEEP. So if we go to the next slide. So the vendor-specific EAP methods are likely to have the same problem, but there isn't much we can do here. And we just need this session ID derivation for ERP and fills, which are in the process of being standardized. So I believe fills at least is in the process of being worked through in IEEE. So there are external specifications which may need this. And then we also have the question of, can we update PEEP too? Which I think the answer is probably it's a good idea. But that's about it. And unlike the previous draft, I think there's essentially no controversy here. And, given a couple of reviews, this document could be published fairly shortly. I think that's it. Yeah, just defining what to use there. And as was noted in the earlier document, we see that all these session IDs and everything are sort of different for every method type. AKA and SIM are not TLS based, so they use something different there. Next slide. I think it's just which documents this updates. And PEEP is not defined in RFC 5247, but 5247 does update PEEP. Next slide, and then we're at the questions.
Okay, that seems pretty straightforward. So again, we'd like to make sure we get some review. And it's that this seems like a draft we could progress fairly quickly. So next up, we have Eep Noob.
Okay, so last time I gave an introduction to, when was that, in Bangkok, gave introduction to this EAP Noob. Sorry? Oh, okay. To this new EAP method, EAP Noob, and with out-of-band authentication. And now I'm just going to explain what's been going on with this draft. So here is the timeline. We've been working on this for quite a while now, and just getting the implementation together, and then polishing it based on the specification together, and then implementing it and in the host APD and WPA supplicant, and modeling and verifying it, and polishing the specification based on that. And I feel that at the moment it's quite mature specification that can actually be implemented. So 2 slides, quick overview of what is this about. So it's an authentication method for EAP. Obviously, the authentication is based on user-assisted out-of-band authentication, one out-of-band message, which can go either from the peer to the server or from the server to the peer. And we don't assume that the device is pre-registered, that it has any credentials or identifiers. It's physical access to the device, so that the peer that authenticates it. And we create, in the process of this out-of-band authentication, an association between the peer and the server. And then this association will be used for re-authentication, so that the user does not need to be involved in any future authentication. Here is an architecture picture. The trick here is to do all the heavy communication, like Diffie-Hellman key exchange and so on, in-band over the EAP channel. And EAP allows the peer device to talk to a remote authentication server even before it is registered and has any credentials. And then the user assists this process, and as a result, we create an association between the device and, in this case, the remote AAA server in the picture. So this out-of-band channel, one way we have implemented it is a dynamic QR code that the user scans with a mobile phone, but it could also be other things like NFC or blinking light. Okay, so then to the recent developments, what have been doing? Well, as said, it is a kind of fairly mature specification, and we have just been making minor tweaks based on the implementation and verification experiences. So one of the changes for the latest version, Draft 5, is improvements in the security consideration section, and then some arranging of the error message codes, and then some rewritten parts about how to do the rekeying in the reconnect exchange so that it would be easier to implement. And for the next version, 6, we are planning to make a little bit bigger change, because currently we use the NAI for, the NAI is updated frequently and has this peer state communicated in it. This was to save one round trip, but probably we'll waste that one round trip in the beginning of the each of these EAP conversations, and then just to deliver the latest peer ID and peer state to the server without keeping updating the NAI. And this is to comply better with RFC 3748, but also because the WPA supplicant implementation at least will be easier. It doesn't have the support for updating the NAI. And then also this will make identifier randomization easier. So one of the things that we have, I think that we have mostly done now since the previous meeting is working on the formal models and verification. So from earlier we have this model of the state machines and the messages of the protocol, and this was used for checking things like deadlock freeness, so liveness properties, and then denial of service resistance in case the attacker intentionally drops messages and we don't want to get stuck because of that. And then we have the model, another model of the cryptographic key exchange properties. And there, the new thing that we have been working on since last meeting is this misbinding question. So correspondence between user intention and what's the pairing that we have in the end. And here is another slide on that. I'm going to talk about this in SAG, so I won't cover it in detail here, but just to summarize, this is a kind of misbinding is an attack that has been known for a long time, since at least the station-to-station protocol 92 by Diffie and others, as a kind of in internet protocols, network security protocols, where you have well-defined identifiers for the endpoints. And the solution generally is fairly simple changes to the, be explicit about the endpoint identifiers. But in device pairing protocols like Bluetooth, we don't have any identifiers for the devices, or maybe they have identifiers, but the identifiers are not meaningful to the user or to the other device. And it is the physical access by user to the devices that defines what is authenticated, what is the correct endpoint. And in these cases, this misbinding actually is possible. So in misbinding attacks, one of the devices that you're trying to pair is compromised. And it has to be compromised to the level that the UI is compromised, the part that communicates with the user in this out-of-band channel. And then that compromised device can actually trick the user to pair do the pairing with another device instead of the compromised device. So one of the endpoints will be the wrong device. And EAP Noob, in effect, does pairing between a cloud, which we can authenticate by, let's say, TLS certificates or some. It has, we have a name for name for the cloud server and can authenticate that, but the device is physically authenticated by the user's physical access to it. So we want it to be any device, and nobody here, neither the server in the cloud side or the user, knows what an identifier for that device should be, and therefore it is vulnerable to this misbinding attacks. So we have a report on this that we have been working on. It's as a university person, it's been an interesting research project just to go over the and model this formally and analyze it and understand how this works. And there's various ways of mitigating this. So better channel binding. It can be seen as a trusted path issue if we had some standard. If the peer devices had some standard, and you could everyone knew how to do a hard reset on them, that could be used as a trusted path. Device certificates can help to bind any identifiers that we may have more strongly to this authentication. And then asset tracking within the organization. If you know your devices, obviously can mitigate this, that you don't accidentally pair the wrong devices. But a little bit more about this on Thursday. So in the hackathon, most of the work and discussions were on how to simplify the code dependencies and about the implementation side. But there was one thing that kind of, I think, will result in a change in the specification that was discussed. So we have been careful from the beginning to kind of provide a future path to anonymous identities or these privacy-friendly identifiers. The peer ID in EAP Noob, the peer identifier currently identifies the peer between this out-of-band. If you reset the device and do another out-of-band authentication, then you get the new peer identifier. But it's a long-term identifier for the peer while it is associated. And we have been careful to keep it so that it can be randomized in the future. But now we actually, in version 5 of the draft, we added this KZ identifier. So this was actually the change made to the implementations already in the autumn, and to make the implementation easier, because the more explicit we are about like key version this identifies the key version if you do key updates, and that turns out that becomes a kind of identifier for the peer. So we think we go back to remove that identifier from the messages sent on the wire and or wireless, and then it just means that the logic for processing the rekeying will be slightly more difficult to implement or to specify, but the text is there in the draft anyway, and we'll remove the identifier, and then it should be okay for version 6 without the identifier. So then there's a question, maybe shouldn't we randomize the peer identifier right now, make it privacy friendly? And why haven't we done that from the beginning? So there is a complex balancing task when you start updating these random identifiers between the level of anonymity, how often you anonymize, and then the reliability, because the peer and the server need to stay in sync. You might lose synchronization. And then the server scalability, because if we need to scale we can easily handle a small number of devices by doing linear search through them, but basically guessing which peer it is, but we can't do that for millions and don't want to. So we don't want to take a stand on what the right balance is there, but we're just making sure that the spec can later be updated with easily with more privacy-friendly identifiers. There's a few other issues that we are working on. These are kind of minor research projects that are spinning off from this, like modeling the error handling and timeouts, and especially timeout related to error handling. we kind of have a hooks in the specification for application level bootstrapping. We export the key for applications, and it is possible to communicate the service application level service URL to the peer to bootstrap its configuration. But I think we can make this more explicit in the specification. Now, currently, I've heard comments from people who don't think it is there, and so we can make it more explicit. The last technical slide on the protocol. So we have been thinking hard about this ways of recovering from dropped messages, because that is a kind of denial of service threat. When there is a change when there is an irreversible change that should happen both on the server and the peer side, that in this case it's the CryptoSuite upgrade that may happen every now and then, and maybe not every year, but we still need a feature for it in the protocol. Then if the last message of that is dropped, the peer and the server might be out of sync, and then we need to allow rollback on one side to recover, but we can't allow rollback to the previous CryptoSuite forever. So eventually there has to be some commit point when you move to the new. And this is something we have been kind of designing very carefully now, that the peer is willing to roll back until it eventually the peer, hopefully, the attacker, denial of service attacker goes away, it stops dropping the critical messages, and then the peer can synchronize. Peer can make sure that the server is synchronized with the new CryptoSuite. There is a similar problem in the initial bootstrapping part with the out-of-band. So the attacker, denial of service attacker, by dropping the critical message, might force the user to repeat this out-of-band step. And we could provide similar protection there, but since we don't have a persistent association yet, we are not really we wouldn't like to add that complexity to the protocol of creating some kind of semi-persistent state that will stay there unlimited time until the denial of service attacker goes away. So it's probably okay to let the user initially repeat the out-of-band step and then never repeat it again, even if there's a denial of service attacker in the rekeying or CryptoSuite update. So I have one slide just that has not really about EAP Noob, but I just want to express some opinions on the base EAP draft, because here it seems the standard solution is now let's build it in EAP TLS and solve this issues there. So like fragmentation, okay, but why not have fragmentation for any EAP method? I know this is controversial, and another thing is that really the EAP specification, regardless of whether it's TLS based or not, should just say that we must have access to the AAA AVPs or like radius attributes and lots of the context to do channel binding in the method, because we also need that. And unless that some specification says that the implementation don't necessarily provide the method this information. So this is something we have been struggling with. And also, I would really like to avoid wasting one round trip time in the beginning and have a method-specific payload in this EAP response identity. Even better if we could put some method-specific payload in EAP success and deliver that to the peer, because this would save lots of communication in many cases. Okay, but that's maybe for another day to discuss. Okay, to summarize, so we have this, I think now pretty nice specification for out-of-band authentication method in EAP, and there seems to be some interest for this, and at some point, if the working group is rechartered, it would be nice if this could be a work item.
Hi,
Eduardo from University of Murcia. I'm working in the project, in the European project IoT Crawler, and we have interest in IPNOOP. Thank you.
Hi, Dan Harkins. In the hackathon, did you what transport did you use to send EAP-NOOB packets back and forth? Was it .1x?
So, yeah, well, transport, you mean, well, there's the wireless network and the radios, and then in the test, it's...
How did you carry EAP? Did you encapsulate it in .1x? Or PANA, or whatever sort of weird encapsulation did you use?
1x.
1x?
Yeah, okay. Yeah, sorry, I didn't see it.
Okay.
Yes, 1x.
So the other thing, I might be missing something by reading your draft, but I'm wondering about how this really provides authentication. It looks like you do an ephemeral Diffie-Hellman, and then you say it's authenticated by verifying a hash that consists of basically the components of the exchange, the public keys and some nonsense and negotiated crypto algorithm cruft. So that doesn't really authenticate the Diffie-Hellman. It just tells you that you did a Diffie-Hellman with somebody, and that somebody, has the same public key that you received that he sent. And so it looks like this is susceptible to a man-in-the-middle attack, where you're doing a Diffie-Hellman with somebody, and he sends you back this authenticating hash that shows that he did take part in the exchange. Well, but it isn't necessarily the device that you think that you're talking to, because maybe he's talking to that same device. So is this? So
it's the out-of-band message that, let's say, one example is the peer device has a display and it shows a dynamic QR code. I scan it, and then with a mobile app which delivers it to the server where I have an account. So that it's the out-of-band communication.
So if the device doesn't have a display, then is this susceptible to this identity misbinding attack that you were talking about in that one slide?
So it needs to have. So the device needs to have either some kind of output or some kind of input. So the output could be as simple as a blinking light, but the protocol has been designed to work also with an input, like a camera that can scan a QR code. So that there's one out-of-band message going one way.
So if it has a blinking light, what does that tell me? How do I verify that this is really the device that I think
the user? So the user would have, if it's a blinking light, the user would have a mobile phone with a camera and an app that scans it, and the user is registered here.
So it scans a blinking light?
Yeah, that's one implementation that we have been working on, but it's a but QR code is easier. I mean, that's standard, or NFC. Those are implemented.
Okay.
Mohit, maybe just to clarify, this hash of all the Diffie-Hellman key exchange is not sent over EAP. It's sent actually out of band, so it's not being that's why it's authenticating. And then to allude to this fact of blinking lights, I don't know if you have looked at Electric Imp, which basically does it the other way, where your phone flashes its screen and the device reads what's being flashed. So Morse code, think of Morse code, flashing lights and sending over Morse code would be like, not a good example, but maybe an example of how you transfer that message.
Is there I think we need to move on to, do you have another slide? I think we need to move on to another.
That's all.
Okay, thank you. Elliot?
Okay. So first of all, I just want to say Nancy's name should be on here too. Nancy's working on this. Sorry, I'm the guy who constantly complains, so it's turnabout's fair play. Nancy's name should be on here too, and I'm hoping in the next round we'll get Dan to help us on security considerations. So this is a very short update. Just a brief review, we have this whole onboarding mechanism that is wireless, that is wired based. Or at least that has makes an assumption of good L2 connectivity. And so actually where it says requires initial IP configuration, what we're saying there is you actually have to have at least L2 connectivity in order to use the Bruschi work that exists. Now in wireless, that's a problem. So the draft here, draft IETF Lear EAP TEAP Bruschi, essentially just crams all the Bruschi stuff into an EAP method. That's the stuff that you've previously seen a couple of times. So I'm not going to waste a whole lot of time doing the description, but to refer you to the draft. Okay, so we made a good number of changes. First of all, we clarified some of the motivation in the text. We've done some we've cleared up some of the flows based on comments from Dan and others. We added a lot of text around what the TLVs actually look like. We added IANA considerations into this, and we didn't have any text on what the NAI looks like, so we now have some text there. Owen did a grammar scrub, which was impressive. There's probably another one needed. So there was some work done on this draft, but there's more work needed. And so one of the key things that we noticed, and we noticed it in the EAP Noob draft too, and we've had some discussion on the list, is that EAP Noob does something like creates a username at eapnoob.net. We were thinking about, well, what are we going to put in our NAI? I don't want to go and reserve a domain name. And so we had a conversation with a couple of people, and Alan chimed in on the list as well. This is really an IANA parameter. And so what we want to do is create, as we go through the standardization process eventually, we want to essentially create some sort of IANA parameter out of .arpa. We think that's the right approach, such that when the working group approves new EAP methods, if they actually name the method as part of the realm, as the realm, you can just do something. You could rather, as part of the NAI, you just stick it in, NAI, username, which can equal the method, and then something like EAP parameters .arpa. This needs a little bit of specification. We know that we have the problem. Alan has talked about some text. I've talked about some text. We need to sort of nail down the text. The question is, where should that go? It can go into EAP. If EAP Noob wants to tackle it, if they're in front of us, that's fine with me. If they're behind us, that's fine with me. We'll do it. Or if we want to do something separately, I don't think it's worth doing something separately, simply because we just want to. It just creates a normative normative block on text, and I've had my fill of normative blocks on text. So this is one issue. Then there are a few things that we need to work on. We just noticed today that we corrected the flow in one part of the document. We didn't actually correct the flow in another part of the document between versions. So we have a little bit of cleanup. And we want to test this out. So between now and the next IETF, we're planning to do a fair amount of coding to look at to code up both something in WPA supplicant and to code up a server for this as well. Now, the other thing that needs to be dealt with is Bruschi is primarily an online registration mechanism. We know that there's a need for an offline registration mechanism. There are a couple out there. We just heard one, actually, just with a previous presentation. The challenge with Bruschi is, well, what happens if some component on the back end isn't available at any given moment? So suppose your CA is offline, your enterprise CA is offline, which is the thing that Stefan Fries noticed. Or suppose you lose internet connectivity so you can't get to the manufacturer in order to do registration. So for anybody who is a Seinfeld fan, I have applied this to Stefan's draft, and we have the soup Nazi who would say on occasion, no soup for you, come back in 2 days. No voucher for you, come back in, and then some specified period of time. So we want to incorporate something along those lines. And Stefan has also had a couple of other ideas, which I think are interesting, which look to make we already have the case where the voucher itself in RFC 8366 is is atomic, if you will. It's a very nice self-enclosed unit, self-describing unit. The voucher request, maybe not as much. And so that's one thing we want to look at and will certainly impact the method. So a fair amount of work needs to be done on offline usage, and separately and likely outside of this working group, we still need to address SID selection in a far more detailed way. And we're looking at that now, both here and at the mostly at the IEEE, and probably that will also take place in the Wi-Fi Alliance, I assume. So there's some more work that needs to be done there. The other thing that's not listed here is we will probably need to take a swing at privacy considerations as part, if not as part of securities considerations, then separately. And the conversation that just occurred with EatNoob is probably just as applicable for this work as well. We just haven't gotten that far. Okay, I think that's it. Yep, that's it. Questions, comments? We're not asking for a working group adoption. We're not ready for it. We have a lot more work to do.
Hi, Florin Babuescu, Broadcom. May you detail what are the issue on SSID selection?
I'm sorry, say it again.
Can you, last bullet point, can you get into some of it there?
Yeah, okay, sure. So I'm some Wi-Fi device. I'm sitting in the middle of Tokyo. I'm hearing 2,000 SIDs. Which one of these SIDs should I try first to see if I should join? Right? How do I identify the correct? How do I even limit the subset of SIDs that I want to even try to join? And if I have only 5 SIDs that I'm listening to, if I'm hearing, I could just hunt. But when you get to a large set of SIDs that you're hearing, a large set of networks with BSS, different BSSs, it gets to be a little bit of a challenge. Okay.
Dan Harkins again. 11AQ defined a pre-association discovery thing, and I believe that IETF already has an OUI that they can use for vendor-specific blobs of data in .11 frames. So you could define a pre-association discovery frame format to solve this problem. I think you can just send out a broadcast and say who supports Brewski, and get back a suitable response.
Yeah, I don't think we want to do it by protocol though, Dan. I think we need something a bit more reducing, if you will, because you don't want to put yourself in a position where the nightmare scenario is that everybody's actually adopted your protocol, and so everybody's announcing that they're doing Brewski, for instance. It'd be nice to have that problem, yeah. Such a nightmare people should have, yeah.
Sorry, then to continue, same thing like what the previous speaker was mentioning. You already have it. ANQP is there. Like you're mentioning handset devices, at least in the context of cellular part, that's how you do it. You may also have beacon, some extra beacon information also to provide it. Right. So the very basic question it is, what is your use case that you are trying to address here?
Right, so the use, so we know we have ANQP, we know we have AQ, right? We know we have these things in the box. Owen actually did a draft that talked about all this. What we don't, the issue is, the use case is if you have, even using ANQP and even using AQ, if you still have a large selection of candidate networks as a result, you still have a hunt problem. In other words, the problem's not yet solved, and probably it needs to be solved at the IEEE, probably not here. But that's my guess. It's a guess at this point.
Thanks, Elliot. Dorothy Stanley. So what I'm hearing from you is we have many mechanisms via protocol for discovery and for gathering additional information from the wireless LAN network. What I'm hearing from you is that really you need additional differentiation, but it sounds to me like it's policy. Like we can give you all this information, but if you're searching and you want to even further funnel down the set of candidates, you're starting to apply perhaps some other characteristics of the network.
So
that sound more like policy.
So I wouldn't reach to the term policy because it gets a little too vague. Let me give a brief example as to what I think we need, but it's very much in the what Elliot thinks, and it's not actually in a draft, okay?
That's fair.
Okay, which is, I think we need something akin to a Bloom filter, in which the device is basically asking the question, are you my mommy? And the bits will be set if a network has received enough information out of band to answer, yes, I'm your mommy. And the idea there is it's not authenticated, but at least that if you have a Bloom filter with a bit set, at least you can then suppose you have a probability of like 99% or something like that, or even 97%. You know, you're going to reduce your hunt numbers down from say 2,000 to a handful, and that actually is something an IoT device could survive. So you don't have to get into policy yet, though. That idea is interesting too, and we could go there, Dorothy. But I would want to, you know, I think it would be fair of you to say, great, Elliot, you just gave me Elliot's top of the mind. Why don't you actually put it on paper? I'll ask you to do the same.
Okay. Well, again, I guess this goes back to the question about use cases.
Yeah.
But as I recall, in AQ, there is a Bloom filter capability.
Yes.
So it's a matter of define, again, what are the parameters or the characteristics that you want to sort on?
Right. And for me, it's specific device identity. Right. So is this particular device meant to join this particular network? Not this type of device, but this particular device. And that's where AQ doesn't quite complete, if I understand.
Okay. Well, getting that input from you is helpful. You know, we can go back and look, is that actually supported in the capabilities that are provided in the Bloom filter? If not, it is potentially a straightforward extension, but let's talk more.
Right. So, and I'm not rushed. I raised the point as an issue. It's not something I intended to try and solve today. It is something that I just said, I know we need to solve it.
Yeah. Right. And I want to be responsive to that. Okay. So let's continue the discussion.
Okay. Hey, thanks for your time.
Thanks, Elliot. Okay, Max.
Hi, everybody. Max Pala from Cable Labs. I want to talk to you about EAP-CRADs. This is some work that we have been thinking about in many different environments, and we wanted to try to propose something to see if the work group might be interested. As many people said in their presentations, we are not ready for asking for the adoption by the work group, but we would like to, introduce the idea and see what the work group think about it, and if the work group would like to work on it, and probably require each other. So, what's the problem that we're trying to address? Well, we deal at Cable Labs we deal with a lot of access networks in different types. Could be Wi-Fi, could be your local home network, could be your wire network, your cable provider, your cellular provider. Many of these access networks use different type of authentications, type of credentials to authenticate your devices, to securely authenticate the devices to do what they need to do in the network. But there's no easy way to actually manage these credentials. So we have EAP. It's great to do authentication, but when it comes to managing these credentials, updating them, etc., we are left with, we have to use other protocols, other methods, maybe require IP connectivity to do that. So it's a little bit of a problem when it comes to managing these credentials from the network administrators. So the idea here is that can we use the EAP channel to actually manage credentials where they actually are used? So we do authentication. Can we manage these credentials, update them, and maybe change type of credentials when your network is ready to change that? It seems that EAP can provide a type of functionality. So we started to think about this, and we identified a possible protocol that we separate in 3 different phases, very simple. The first is the initialization phase, kind of a discovery of what type of provisioning protocols are supported through this method, and the selection of this method. The second phase would be the managing phase, where you actually encapsulate your preferred credentials managing protocol through EAP. So very simple idea. And then an optional third phase that allows you to validate the credentials to make sure that these credentials are really installed properly and can be used by the device. So this is just an example of the message flow that we have today. And I have some considerations about it in the future, but the usual message exchange here, the first message will probably be from the server that says this is the type of protocols that I support and all the parameters that you might need to know about me. And the peer actually selects the ones that it supports, so they want to use for that particular credentials that it wants to use. And the protocol can proceed to the second phase where all the messages for the selected protocol are actually encapsulated. When the second phase is finished, then optionally the server can request the client, the peer, to actually verify the credentials, and this allows them to see if there are some type of credentials that need to be verified. Like, for example, cryptographic credentials might be useful to verify that the peer can actually use them after you deliver them. But this is an optional feature, so it could be used to verify those. There's a lot of work that needs to be done, and this is why we are not asking for adoption at this stage, because there's many different things that we're still thinking about. One of the things that came out through discussion on the list was maybe we can simplify the proposal. So many EAP methods, they provide support for fragmentation because they assume that they can be used not inside another method that provides already that support. After exchanging some emails, it seems that adding the requirement for, you can use this method only in an encapsulated method that provides fragmentation support and authentication of the channel is not, initially I thought it was maybe a big requirement, but it turns out that many people on the list agree that this is something that we can assume. So if we put a clear disclaimer in the method, we could actually simplify a lot of the messages and avoid duplication of acknowledged messages because you're trying to do fragmentation support in yours, and maybe the encapsulation protocol already has fragmentation support. And the other piece that is still missing, but we were think about it from the beginning, is that we couldn't find an easy provisioning protocol to deliver credentials that are not certificates or keys. We have like Acme, CMP, and many others for certificates, but delivering something simple as a token or a username, password, or a one-time token, reusable tokens, etc., is not well defined, or we could not really say, oh, you can use this protocol easily referred to that. So we might need to define one of our own inside the method. That could be as simple as deliver this blob of data without really requiring that the server or the peer really knows about that. Then next steps. Of course, as we would like to see this idea to move forward in the work group. We would really like to have a lot of inputs for that, but we discussed this in the previous meetings. Until we definitely require a rechartering for this, and we realize that this effort might take resources out of some other work that still needs to be completed first. Some work is very close to be completed, so it might be useful to start a discussion also on this. Maybe, of course, we would like to provide to have some feedback from the work group. I know it's not a work group item yet, but it would be useful so that if it ever gets to the work group document as a work group document, we're already on the right track. So, for example, should we provide an authentication mechanism instead of saying just assume to be used in a tunneling mode, like adding some form of key exchange like EAP-NOOB, or can we just say, no, we want a simple method that can be implemented and we leverage what already exists? And the other point that we still have not decided is about this generic provisioning messages that we should define in EAP creds for credentials and not certificates. Should we define that directly in this document as part of the method itself, or should we define it in another document and just keep this document to be to just provide the encapsulation mechanism and then define that in a separate one? So these are some of the questions that we have. So to get the sense of, the work group, where the work group is, it would be probably useful for us to understand, is it something that the work group would like to work on, managing these credentials? Not, we have our own idea, our own proposal, but, the work group might have something else, coming up with something else. But the point is, do you think that managing the credentials this way could be useful, something that you guys want to see it, or in one way or the other, or not? And if there is this interest, how can we work on a charter item to include maybe a generic bullet point from this point of view, or a specific document as we have in the charters for other work items? So this is all. It's a simple idea, just an initial proposal, but I would like to see if there's interest.
So just one quick thing from the chairs. I think we are making progress on our work items. So I think it may be a good time for us to get together with the AD who's coming in and see, what the potential here is, because we have a number of proposals coming in that are somewhat similar. They're all trying to address slightly different or different problems, but the kind of theme is similar, of trying to either provision access or manage some type of credential, whether it's to identify the network or identify the supplicant to the network. I think this is something we should start looking at, but I think we'll have a chat with the AD to see what's going on, what their view is. But for the remaining part of the time, if people have things they want to bring up on this topic, please do.
Yes, so again, Florin Babescu, Broadcom. From our perspective, I think we'd first start from what type of credentials are you trying to manage? At least in your context as being cable apps, I assume, I would consider certificate-based scheme and then SIM-based credentials. Other than this, actually, I'm not so sure that you may need. So I would rather like you to see it focused around these lines.
Oh, definitely, yes. Certificates-based authentication is, one of the things that we look for. But we realize that access network might use other type of devices like one-time tokens or auth, reusable tokens. So we would like to be a little more generic than just focusing on certificates. But definitely, that's something that we want to support very well.
Hi, so Elliot here. I read this draft. I have two reactions. First, sort of at a high level, as Joe mentioned, that there's a lot of drafts that are covering this ground now, and there's going to be a side meeting on Wednesday at 2:00, in which we talk about onboarding. It's on the 104 meetings wiki, the side meetings wiki, and I'll post an email to this list just to say where it is shortly, just so that people know. The second point has to do more specifically with the abstracting that you're doing. What I'm in going through the EAP Bruschi draft, what I'm learning, and I don't know if the new people can speak to this too, is that there's a lot of back and forth flows that need to happen in a particular order or a particular set of orders based on the needs of the peer at a given time. So for instance, if the peer is able to authenticate properly because on both ends, then you don't need to go through a registration flow and you jump over that step, right? Because you essentially can go right to EAP success if in fact each of you can authenticate. On the other hand, if you don't have the trust anchor, then you have to do the Bruschi dance, for instance. And so, and so you need to do that component, or you need to do the certificate enrollment step if your certificate has expired. So there's all these sort of conditionals that occur. And I don't think, so one of the areas I think your draft should work on it is if you're going to subsume all these methods, which it feels like that's what you want to do, the method to eat all methods. I'm not opposed to that per se, but think about whether that's the right thing to do given all these conditionals, and actually really an eat method is just an additional conditional, right? The question is whether you want to glom these things all in which case your document's going to get very, very, very big.
No, thanks for the consideration. That's a very good one. Yes, there's a lot of different, depending on the type of protocol that you're using, there's definitely a lot of details that needs to be taken into consideration. I hear what you're saying, and definitely we will try to, my initial idea was to try to provide some of these messages. How do you encode these messages for some of the most used protocols, and leave to the implementers to define others. But yes, this is something that implementers will have to, once we discuss this, we will have to look into that more. But I guess we don't have more time, so
yeah.
Thanks everybody.
Yeah, we're out of time. Thanks everybody for coming, and for those presenters, thanks. I think this was a good meeting. And yeah, bye-bye. Yeah, I mean, right now we're still working through. We're kind of feel like we're starting to, get critical mass on that. There's a lot of these things are similar, but not the same. And so, yeah, I just